Aloha, Richard Halverson here. This is ICS321, and today is the third week of the class, third cycle. It's June 4th. And so let me share my screen. And so here we are. And can you see my screen? And I'm sharing my screen, right, Karen?
Yes, sorry, I was having a hard time with the unmute.
Okay. Sometimes there's a big green line around when I'm recording, and sometimes, well, I don't know. Okay, so 321. All right, so syllabus, we are here. So we're gonna go into chapter 2. Last time I explained the assignments, so I guess I don't need to do that. Let me go to our chapter 2. Let's see, how far did we get? I can't remember how far we got. Let me just quickly take a peek at I'm only teaching one class this summer, and I can't remember how. I revealed that I'm wearing the same shirt I wore 3 days ago. Oh,
that's fine. I wear the same 5 shirts anyway.
I know it's okay. So where are we? Oh, so I go like this. We didn't get past section 2.1, huh?
Yeah.
That's all the part that we got. Okay.
I think we did part of that, and I think you briefly went into 2.9 a bit just to say it replaced.
Right.
Yeah.
Right. I started babbling. Okay. Okay. So we're starting with section 2.2 today, and we're discussing relations, and let's see, the relational model was covered before, database models. It's got rows and columns are fields, and okay. So all data in a relational database is structured as tables, and a table is a collection of data. There's columns, which are like the fields. Each column has a different name. A row is a set of values, and a cell is the intersection of a row and a column, and that's a single particular value or attribute. The row represents an entity, and the column represents a particular feature or attribute of the of each row. It could be different, could be the same as other rows, and so on. So that's a cell. And so here, here's an example. These participation activities. I think they're like 20% of your grade, and all they are is clicking through, and it's the way I can tell if you've actually read and absorbed well enough to be able to do these participation activities. Your comprehension of the test. So it's basically just clicking through this so you understand it, and this is simply explaining tables and columns. Each value appears in a cell, in a single cell, and a row is, the first row is the table for this person, and different the first row of the table 4500 is a salary. This is all simple. I mean, especially since we're all familiar with spreadsheets, similar thing. Some of the things are, though, that there can only be one value in a cell. With spreadsheets, you can kind of do anything you want, but there's specific rules regarding databases that are enforced by the database engine underneath, which is why databases are much better for managing large amounts of data, because of all these restrictions that keep everything consistent. So this just helps you this just makes sure you understand so see, I got all the points for this, and there's some questions here. This is very simple stuff. which choice is a column name, and we see that there's column names. Obviously, it's this one. And what's interesting about these tests, of course, is you can just click around until you get the right answer, but and you still get all the points, but you should try to read it and try to get the right answer every time. Which choice is a cell value? Well, it's not ID because that's a column. This is a Elsa Brinks is not a cell value because I guess we're referring to this table up here, but I guess 30500 is a cell value. See, it's the salary of Sam Snead. So of course it's this one. All right, so here we're talking about data types. Relational databases support many different data types, and these are data types of a cell. Okay, so in some views of relational algebra, we consider the table itself, the whole thing, the relation itself, as a particular data type. Here we're referring to the cells that there can be many cells in a column or many cells in a row and so on. So there's integer types, of course, decimal, character. These are like integer, floating point, and character, like in a programming language. A date data type is very common in all databases. Binary data types, which are used to store images and so on. Spatial data types are store geometric information, and that has to do with storing coordinates and so on. And so there can be more than one value associated with one type. For for storing a square, we would be storing four data points and so on. And a document is textual data like XML or JavaScript object notation object and so on. So here's some examples. See, here's an example of spatial. These are points, and this would be a document and so on. And here, these participation activities are simply you drag the right answers. This is real easy stuff here. And more participation activities, structural rules. Tables are normalized, and exactly one value exists per cell, no duplicate column names, and no duplicate rows. Okay, so that's important, this concept of a normalized table. See, so this is obviously illegal because if there's no values in here. This is obviously illegal because two columns have the same name, and this is obviously illegal because there's duplicates. Now, these are normalized tables. You can have something like this in a MySQL database. You can create a MySQL table. You can create a MySQL table and create a table that looks just like this, and that's because the database table itself, at least MySQL does not enforce that part of these structural rules. For that to be enforced, you need to have a primary key. You need to define a key, and the key can be all the columns in the table. The key can include, say, as long as each row is different. If there's nothing else that you can say about the table other than guaranteed each row is different, then you can declare the primary key being a collection of all the columns. A primary key doesn't need to be one column. It can be two columns together, and that's the primary key. Or carrying it to the extreme, it can be all the columns. Well, this here, if we take all the columns as the key, as the primary key, we still have a duplicate, and that's this third one here. So that's the idea. How many values may appear in a cell? Exactly one. Where are duplicate column names allowed? Never. Now, it also turns out that in MySQL, if you're doing a select operation and you're joining tables, it's possible for it to produce a table that has duplicate column names. It's possible, and so again, the database itself is not going to necessarily enforce that. You have to enforce it by, you know, some other means, which we'll see later. All right, so this is a never. Oh. Oh, as long as they come from different tables. Okay, yeah, so this is what I was talking about. When you take two tables and you join them together, and there's duplicate and there's columns in each of them that have the same name, then it's possible that the operation of joining them is going to produce a table that has duplicate column names, but that's not going to be a single physical table. It's not going to be a single physical table. It's going to be a virtual table. It's going to be a joined table, or it's going to be a view. It's called a view. But anyway, yeah, so it looks like this is the answer. And I still get all the points. What does the principle of data independence mean? Performance of a query is not related to physical data. I'm not sure what the answer is to this. The result of a database query is not affected by the physical organization. Data independence. Relational databases obey the principle of data independence, which states that rows and columns of a table have no order. Well, okay. Is it this one? No, it's not. The result of a database query is not affected by the physical organization of data on the storage device. Well, maybe I didn't read far enough. Although the values of the rows and columns are stored sequentially on a storage device, such as a disk drive, the sequence is arbitrary and does not affect the results of the database query. So I guess that's what I should have done before. All right, can a driver's license information, how can driver's license information be added to the employee table? What is the employee table? Okay, so what are the choices? Driver's licenses cannot be added since employee table is not. By creating another column name ID, by creating another column such as a new name. Oh, how about that? Yeah, okay. All right, null values. Null is a special value which represents missing data. It's either unknown or inapplicable. In the compensation table below, the null is a birth date means it's unknown. Since everyone has a birth date, also, if engineering employees are never paid a bonus, then null means it's inapplicable. See, so these are two examples of where null might appear in a table. And in this case, it's because we don't have, the information is missing because everybody has a birth date. And here it's just simply means it's not applicable. And of course, in the primary key, if the ID is the primary key, you have to make sure that there's never a null value. To prohibit a null value, a column can be designated not null. And I think I showed you that last time. A database rejects any attempt to insert a row that with missing data. So so you should click through this to see what they're trying to show you. Okay, so refer to this table. What does a null in the name column represent? Unknown, inapplicable, either unknown. It must be unknown. In the bonus column of the Lisa Ellison row, what does 0 represent? It would be this one, I would think. Yeah. If the department column is designated not null, what happens when a user attempts to insert a new employee without a department value? The database, no, it does not. Database accepts, no, the database rejects the insert. Yes, it should reject the insert. Okay, so an operator is a symbol that computes a value from one or more values called operands, just a regular old expression. SQL language is has several operators. So these are these infix operators where the two operands are on the on either side of the operator. These are operators where when it's evaluated, it ends up being true. The result is true or false. It's not going to be a value, it's a value, but the value, it's Boolean value, the true or false. And then these logical operators are also operators that can have two values on each side that evaluate to true or false. So these operators are going to have any kind of numerical values on each side, and the result is going to be a numerical value. These operators are going to have numerical values on each side, but the result is going to be a true or false. And these operators are going to have values on each side that are going to be true or false. They can be expressions that evaluate to true or false. Whenever an arithmetic or a comparison operator have more than one null operands, the result is null. So the keywords is null returns true when compared to a null, and is used instead of an equal sign when you're comparing nulls. So if you want to find out if something is equal to null, you use is null rather than equal null. So in this example, in these examples, this is going to evaluate to null. Well, let's see what this thing does. Okay, so that one, salary and bonus is null. So the whole thing is null. So null is greater than 3,000 is null. So select compensation where it's supposed to tell me. The select statement does not select a name from a row where the where clause is null. So Larry Ellison is not selected. So I guess what we're supposed to conclude from this is a select statement does not select a name from a row where when the where clause is null. So when the where clause is null, then okay, so this select statement, it is going to select okay, so it's going to ignore the null. It does select the other two. It's all three of them have the salary greater than 3,000 or 30,000. All three of them have a salary greater than 30,000. So you'd think that all of them would be selected because you would think that null would be interpreted as 0, but that's not the case. Null isn't any expression that has null in it is going to end up being null. So And so salary plus bonus is null. Null is not greater than 3,000. When null is in the expression, when null is in an expression, the expression evaluates to null, and where null null is going to be interpreted as false in a where clause. I know it's confusing, so maybe you should just not use null, or if you're going to use null in a where clause, you look for null, evaluate it explicitly, so you separate out the null part. But anyway, for this select statement, the line the row where it's got something that evaluates to null for salary plus bonus will be ignored, but the other two are not ignored, because when you do this calculation on the other two, it ends up being true. The salary is greater than 30,000, so adding a bonus only makes it more, and so it ends up. So this is going to be true for Sam and Maria, but not Lisa, because there's a null in bonus there. The next one here is this doesn't work, because you don't say birth date equals null. You have to say birth date is null. And this one works. Okay. All right, so here, times. Okay, so we're only on 3. Okay, I better get select. Okay, so here, so have we talked about create statements yet? I don't recall going over create statements. Let me just quickly, can I do a search or something? Well, anyway. This is a SQL statement to create a table, and so it's going to create a table with let me go to retrieve, and everybody's got this ICS321.com/cpanel, and I'm going to log in here. And I'm going to create a database table. I'm going to create a database called these the only databases I have, I guess. Yeah. Okay, well, anyway, I'm going to create a database table called test. Okay, and that's all I'm going to do. So now when I go to PHPMyAdmin, I have a database called test. Click on test, and it's a blank database. And so I'm going to show you that I can take this thing here and do a copy and go over here, here, and do a SQL. I'm in database test. I'm going to pop this SQL in there. Can I paste it? Copy. Paste. And go, and it creates a table called song. So inside my test, now inside the test table, has got a test database. It's got a table called song. It's empty when I do a select from song. But it's got all the columns there, and then I can insert, copy, and go over here, and I'll do some more SQL, and I will clear this, and I'll do a paste. And so this is going to insert these values in there. And now when I look at table song, there they are, nice values. And so now when I do this select here, I can do like this. When I do this select song where artist is null, I should get need you now, and there, that's the way love goes. And so that's what that is. All right, so I just want to show you that. So we can run this and we get to participation activity, run it. And now I got a check mark there. And this is the database and this is the query. So we're supposed to, you can go through this. Null and aggregate functions. Okay, now we're doing aggregate functions. It's 1106. There's this sum, average, max, min. So you can say like this, select the sum of salary plus the sum of bonus equals compensation. And it's going to produce one record result like that. So so you can do sum, you can do average, you can do max, you can do min. And so here we're select statement with no where clause. So you just sum salary and bonus from compensation, and it's going to produce 7. Salary is going to be that. Oh, just going through the steps. Bonus is going to be that. Okay. So I guess it just ignores the null. All right. So you can go through these. Null in logic is, it's kind of, when null is in a Boolean expression, that is an expression that is normally evaluates to true or false. Normally with Boolean expressions, when we're anding, if you got two things and you and them, two things are true and you and them together, that's true. If anything anded with a false is false. They both have to be true for it to be true. If anything is either of them is false, it's false. And if you and anything with null, it ends up being null. I'm pretty sure. So if false and null false and null is false. Okay, false, and null is false. Null and false is false. When you OR them together, it's null. So it's kind of like null is, kind of think of it as null as being in the middle of true and false. If true and null added together is null, and true and null OR together is true. False and null added together is false. If they're OR together, it's null. So anyway, here's a challenge activity, and so you should go through these. I'll do one of them. Let's see. Select ISO code 2 from country. Country is the table where area is null. So we have area of null. Area is null. We're supposed to select ISO code. So that would be EG, I guess. EG. Selecting the ISO code from country where area is null. It's only this one, EG. So it's that one. Great. Select max population from country. So here we have the populations. Well, I guess it would be 2507 to 25,770,000 plus 51,039,000 would be something like 6. Let's see, 6, 4, 6, 4, 6, 7. 0, 0, 0, 0. Max. Oh, Max, I was doing sum. Right?
Oh yeah, sorry.
Instead of maxing them. Yeah, stupid. Silly me. All right. So it's going to have me do it again. Min. Let's see. Oh, okay. So I guess it's this one. Oh, area. It's this one.
I did that before too.
I'm still, don't worry, I'm still getting it all the points though. Min population. Okay. This one. Min population. Okay. Well, anyway, you can do the rest of them. Okay, primary and foreign keys. Okay, this is pretty important. So a primary key is a column or a group of columns used to identify a row. And so in the employee table here, we have we can declare ID as the primary key. And the reason we wouldn't use name as a primary key, because it's possible that you have 2 employees with exactly the same name. And of course, salary, it's possible to have 2 employees that have exactly the same salary. So we have this third, we put in this key here, and it's nice when keys sort of aren't related to anything, and they're just sort of, surrogates, is a term that they use. And this doesn't mean anything other than it's a unique identifier for this record, which is Lisa Ellison's record. And so that's primary keys. Everybody's got to have a key. And a new employee can be added with 5384. No, because that one's already being used. And there can be composite primary keys. And so this, like for example, let's say you wanted to have a table called family, which has the family of these employees. And so you might have a table called family, and then you can have a composite primary key for each person. And let's say we have, this is Lisa Ellison's family. And so that's why we have Lisa Ellison's ID here, Lisa Ellison's ID. And then and then of course, Lisa can have any number of people in her family. So we can just have this second column here, which is going to have a unique number for each ID field. So both this together is unique. ID along with number, the composite is unique. Okay, so that's composite primary keys. And then foreign keys are columns in a table that are actually a primary key, which represent a primary key of another table, the column of another table. And so here, for example, we have a table called department, and every department, it looks like, except one. Most departments have an employee that is a manager, a single employee, just one manager for a department. And so instead of in the department table, instead of actually having the manager information in there, the manager is just an employee, and it's going to be an employee that is already in an employee table, the employee table that we already have. And so in the department table, we can just have a manager column, and that would be the ID or the primary key of the employee that is the manager of that department. And it can be null. Null can mean it has no manager, or it can mean that they haven't assigned a manager or whatever. So in this department table, manager is a foreign key. Code is the primary key of this table. This manager, this field here is a foreign key, which is the link to the primary key of the employee. All right, so you can excuse me, you can go through this. Yes, has to be the same. True, data types have to be the same. So special case. Several foreign keys may refer to the same primary key. So here we have a case where manager is a foreign key into the employee table, and also assistant is a foreign key into the same table. So you can have this. You can also have this, where you can have a let's say each employee has a manager. And so in the employee table, you can have the employee ID of that employee's manager. So here, Lisa Ellison's manager is 8820, whoever 8820 is. Oh, it looks like it's Jiho Chen. So Lisa Ellison's manager is Jiho Chen. In fact, everybody in here's manager is Jiho Chen, except for Jiho Chen. Jiho Chen doesn't have a manager. Maybe Jiho owns the company or something. I don't know. And here's the composite foreign key referring to a composite key. So here we have a health plan, and it's a health plan table and a family table, and we have the employee ID and dependent number, and it's referring to this. It might not be. Might not be the same. This dependent number may or may not refer to this side. It probably does refer to this number here. Is that what this thing says? Not sure. It's not. It may be that this dependent number is the same as this dependent number as this number, but it's not necessarily the case. All right, so match the table with the special case. All right, we can go through this. Let's just do one of these. Select the country name for country where where this is equal to AR, that'd be this one equal to AR. And we're supposed to select the country name. Is this a trick question? Nope. Based on the data in the country table, select the properties that satisfy by the column, satisfied by the column population. All right, population is, it's not going to be unique. It's possible that two countries have the same population. It's select the properties satisfied by the column population. Well, this is not, that's not one of them. That's not one of them. This minimal. I don't know. Oh, well, okay. No population cannot be the primary key because a primary key can't have any null fields in it. I'm not gonna check any one of these up here, but I probably am gonna get one wrong. Minimal, no. Population is minimal since population is a single column.
That one's tricky. I thought it was none of the choices.
I wonder what this means. Does it talk about it up here? Minimal.
Oh wait. Oh no, I was just reading in. There's like, oh yeah, I'm at the same place as you.
Okay. All right, I'm gonna have to study what minimal is offline, so I'll make myself a note here. Section 2.4. I don't know what they're talking about, but anyway, we can still. Does that mean I can't get all the points? What happens if I do the next one? TLD. TLD is what is TLD? I think that's a abbreviation for a country or something. Oh, top level domain. Oh yeah, every content. Oh no, every country is going to have a different.
So that would be unique. What?
I guess so. I guess so.
Unique and
not null would be
not
true.
null.
And I don't
and
know.
Then I guess also minimal.
I'm gonna let's put that and see.
Okay. Oh, okay.
Minimum because it's a single column. I guess that's what it means.
Okay.
All right. Well, now we know.
Okay.
Okay. All right. Let's go. Let's move on. Referential integrity. Okay, this is important because it's I think I better save. Okay, so a fully null foreign key is a simple or composite foreign key in which all columns are null. Referential integrity requires that all foreign key values must either be fully null or match some primary key value. Okay. In a relational database, foreign keys must obey referential integrity at all times. Occasionally, data errors are incomplete. Okay. All right. So, referential integrity rules. This for every. Okay. Let's see what this is. Okay. So this is breaking the rules. We have a manager in here. In this, it's 4407, but there's no employee 4407, so you can't have that. So that would never occur. The two ways that this could have gotten there are there was once an employee named 4407. There was once at one time there was a 4407 employee, but then somebody went and deleted the 4407 employee. And which caused this to be there, and it's not pointing to anything. Well, the database, when referential integrity rules are enforced, the database would not have allowed that employee 4407, would not have allowed that employee to be deleted while this thing was still referring to it. Okay, so, and then the second way that this thing could have gotten in there is that somebody just made an error, and when they inserted human resources, they inserted 4407 when really they didn't mean 4407, they meant somebody else. And that would never happen because the database would not let you put 4407 in there unless there was an employee named 4407. And I think what this fully null means is that it would allow you to put a null in there, but it would not, so it's got to be null. So it's got to be there isn't one over here. Anyway, so that's what referential integrity enforces. What else are they here? Okay, does not match any other ID value. Okay, here 63814 does not match any. Okay, so you remember before when we had these two tables, I wasn't sure whether this was the same as this, and I was wondering that like these numbers could be different than these numbers just because it could be a different table. This could be different. It's possible to have it's possible to have a family member that's not covered by the health plan, but I see in this case we have a 631 number 4, and there and 6381. There's only 3 6381s. There is no 63. There's no fourth one. So I guess anyway. So that's another example of a referential integrity violation. And this last one is going to be where, oh yeah, that's there has to be a, yeah, this is a referential integrity violation because it's partially null. I see what they mean by partially null and fully null. So fully null means they're both null. So anyway, all right. So you can go through this. Okay, so there's so when you're setting up this referential integrity, you can say what happens. Let's say you did have where you can set it up so let's say in the case where you had a manager in there and you wanted to delete an employee. I said earlier that if it wouldn't let you delete the employee if there was a department that had a manager still referencing the employee. Okay, I said that the database wouldn't let you delete the employee. Well, that's under a restrict rule. But there's a cascade. You could instead say cascade the delete. And so if you deleted the employee, so if we were cascading, if we deleted Lisa Ellison, then that would automatically delete engineering also, because if Lisa Ellison's getting deleted, then this manager's getting deleted, and you can't have if Lisa Ellison's getting deleted, you can't have a field over here that refers to somebody that's not over here. So if you're going to cascade your deletes, when you delete Lisa Ellison, you end up deleting this whole field also. Okay, that's another way. A third way is to set it at null, where if you delete Lisa Ellison, then this thing gets set to null. Okay, that's a third way. And then a fourth way would be set it to the default, where that would presume that there's some sort of default value that's set that's not null, some other value. There could be some, maybe it's not the manager. Maybe if there's a department that doesn't have the manager, the manager is now going to be like the president of the company or something. I don't know. Maybe you bypass the manager and it's going to be the next guy up or something. So then that could be a default. But anyway, when you're setting up these primary these keys, like this particular database has got keys here. Here we are defining, and you're going to see all this later, but we're defining, this is foreign key constraints. And if you delete, you can either restrict or you can say no action where you just leave it. That would violate these rules, or set it to null or cascade the delete. And same with updating. I'm not going to change any of this, but the no action would mean that you would allow there to be an integrity violation. So I don't know, I guess you could do that. So here you can go through this. It's 11:30. Okay, so I think I'm gonna, maybe I'll just do this one last thing, and then next time we'll start with the joins. Joins is a good place to start. All right, so let's just try this out. What is this thing? With restrict referential integrity, what happens if ISO code of Iraq is updated to XXX? Okay, so we're doing an update. We're not doing a delete. We're doing an update, and it's a restriction. Okay, is this going to be different? Okay, so what happens if the ISO code 2 of Iraq is updated? Okay, so ISO code 2 of Iraq. What happens when this one is updated to XX? I don't think it's allowed because it's going to make this one like an orphan or something. Let's see. Update is rejected. Let's see if this is correct. Ah, yes, it's right. Okay, so the update is rejected. What's next? With set null referential integrity, what happens when the row containing China is deleted from the country table? Here's the country table. Here's China. What happens if China is deleted? Then that means anything down here with CN would get set to null. What happens if the row containing is deleted from the country table? It's deleted. And what happens to the row and ID? That must be set to null. Okay. With set default referential integrity, what happens when the code of Guinea is updated to XX? This is updated to XX. What happens to this? What happens to this row? All right. I guess it gets updated. What happens with that? I guess it gets set to the specified default value. And let's just do the last one here too. The cascade referential integrity. What happens when Fiji is updated to XX? What happens when this changes to XX? Well, that's changed to XX. What happens to this? Well, this also gets changed to XX. See, so it propagates, it cascades. So anyway, we finished 1.6, and I think we're going to we might spend 2 more days on this. So that means next week I might schedule more than one. I'll schedule 3 classes. What is next week is well, I'm not sharing my screen anymore. So I will come out with a new schedule next week, and maybe I'll do three classes next week. And but again, don't have to attend. You can just watch the video later in the day. And thank you, Taryn, for coming again today.
Oh, thanks. No, thank you for holding it. Thank you.
Okay, we will see you next week.
Cool. Thank you. Take care. Bye. Thanks.
Bye.